What's up guys, C113 here, and in today's video, we're going to be taking a look at the Maxoak Bluetti AC100 solar power station. Alright guys, so this is the Maxoak Bluetti AC100. Now, hopefully you guys are understanding about the camera angle being a little bit different and me coming from behind the camera instead of being in front of the camera as I normally am. The box is just too big. Now, other than removing my information off the side of the box here, this is how it came. It ships in this container, it ships in this box. So real quick, as always, the link will be in the description if you want to check it out. But this is the AC100. This has a 1,000 watt hour lithium battery inside. It has a 600 watt inverter. Now, it's not super clear, at least on the description and what I could find online, about what the peak watts are for the inverter, so what the surge wattage is capable of. But 600 watts is the maximum continuous wattage. And this thing can only accept a maximum of 170 watts of charging input, and it does have a regulated output for the 12 volt port. But of course, we're going to check all this stuff. So enough talking, let's take a look at what's in the box and what you get for what I paid at the time of purchase, which was $850 US with a $50 off coupon. So let's go ahead and crack this thing open. Now this thing is noticeably larger than my Maxoak G500, just by the weight alone. But it does seem to offer a much better value proposition than, let's say, the Bluetti 150 or the 1500 watt hour model. So let's see how this thing stacks up. Now, one of the reasons someone might want to go with something like this, even though there are cheaper units on the market, maybe not in this exact battery capacity, but similar, is that Bluetti uses automotive grade cells. Now, we'll have to take a look and see if they're actually using the pouch cells that they use on their 150 model. But either way, they are guaranteeing a minimum of 1,000 to 2,000, they say, cycles before reaching 80% capacity. Now that is very, very good. So these seem to be, from what I understand, automotive cells capable of a 3C discharge rate. And what that basically means is at the standard draw you're gonna get, especially with only a 600 watt inverter on this unit, you're not gonna be stressing out these cells at all. So in other units where they might utilize 1C max discharge rate cells, and those are in a unit with a similarly sized inverter, you're going to be drawing a lot more power out of those batteries. You're going to be a lot closer to that threshold of what they can handle. So I think that is a big selling point here, is just the quality of the cells. But again, we'll have to see what's inside. So we'll crack that open at some point. All right. So I don't know if you guys can, all right, I'm gonna try and get this on frame here. So very nicely packaged, honestly. We'll just grab the unit, pull the unit out. Very nicely packaged. Yeah, this is definitely a lot bigger and heavier than the Maxoak G500. And then it includes a little carrying bag, which is nice. You know what, the colors are a little strange, but they kind of have like a retro feel, kind of like 90s-ish. So I like it. I mean, it's nice that they include something. All right, and then we've got our warranty card and our manual here. We'll look at that in a minute. But let's just take a look at our power adapter. I'm sure you guys are all wondering, this thing's got 1,000 watt hours. What do they include for an AC adapter? Well, unfortunately, guys, you guys might be a little disappointed. I'll show you what we're working with here. Yeah, I read this ahead of time. So you'll see here, this is the AC adapter, and the output on this is 17.4 volts at 6 amps. Now that's about 104.4 watts. That is not a lot of power, especially considering the Maxoak G500, which is a much smaller 500 watt hour unit, came with a 90 watt charger out of the box. So to have something that's only maybe 14 watts more powerful for double the battery capacity, that's a little disappointing. However, all right, there is the bonus that this thing does charge a little bit faster, but not a lot, and that's could be a deal breaker for some. We'll get into that. So let's just take a look at all the other cables that are included. We've got an included Type-C cable. Note this thing does not charge from Type-C, but they just include this, which is nice. And you get your 8mm, technically 7.9, but 8mm port to MC4 connector cable. Nice. And you get a 12 volt adapter, but interestingly, this isn't actually the 8mm. I don't know what that is. You'll see here. We'll take a look at the manual and see what they're talking about here, but I'm guessing this is just to power 12 volt accessories. I'm almost positive you can't actually charge this from 12 volts because I'm pretty sure the nominal pack voltage is too high and you wouldn't ever be able to charge it. I'm sure you could charge it from 24 volts, but you couldn't charge it from a 12 volt charging system. So I'll have to figure out what this is for, but I'm guessing it's probably for common 12 volt appliance type adapters or something. I don't know what this is for exactly. But that's what's included in the box. So I want to take a look at the manual and I'll be right back. Alright guys, so to make things a little easier to see, I flipped the unit on its back here so that we can look at the display side of things. Now I do want to clarify, I looked through the manual and it did describe this as what was supposed to be a 12 volt to 7.9 or 8mm connector, but this is clearly too small. And I'm not sure why they would include this honestly anyway, because if we look at the input, all right, if we look at the input here, as stated both on the back of the unit and in the manual, you'll see that the required charging voltage is 16 to 40 volts. So that's still way too high to run off of a 12 volt system. So you couldn't run this off of just, a standard car 12 volt alternator charging system. Now, if you have a 24 volt system in an RV or something like that, then you could definitely charge it. But either way, you wouldn't be able to use this because it's not the correct connector. So Maxoak, if you're watching this, I don't know what this is for, but I know that there are certain 12 volt devices that can use this adapter, but in the manual, it describes this as a 79, you'll see here, number 3, and it's described as a cigarette lighter cable, cigarette port to 7909 connector. So again, that is the 8mm or 7.9mm connector. So that is not what this is though. This is way too small. So I don't know what that is, but like I said, either way, it wouldn't have been terribly useful. The way you'd really want to charge this from a 12 volt source is, unfortunately, you're going to need an inverter, and you have to use the AC adapter for that. All right, so let's take a look at the interface, go over some of the features here, and then we'll do some testing to see what kind of power we can actually put into this. Because surprisingly, even though the product page mentions a 170 watt max charging input, that isn't specified anywhere in the manual. So I'm curious to see if I hook up my external power supply and crank up the volts and the amps to see exactly how much it's going to take. So first, let's go over the basic features. So right here in your DC output, you've got your USB-C port capable of 45 watts output. Now that is a huge plus. Now on the Maxoak G500 here, it's also got a USB-C port, but unfortunately, it's only limited to 18 watts. And man, is that slow when I'm trying to charge my iPad. So something like this is going to be great for iPads, tablets, and even laptops, because 18 watts on the Maxoak is just too slow. And really, the only way you can charge a laptop with that is to, well, turn the laptop off and then just plug it in. With something like this, with 45 watts, at least for some lower power laptops, you could probably use the laptop at the same time and still charge it. And then definitely if you were to close the laptop and put it to sleep, you could definitely charge it pretty efficiently. And then you've got some USB ports here. Now these are all 5 volt 3 amp output. Now these aren't quick charge enabled, but given that they are capable of up to 15 watts, even just standard without a quick charge protocol, that's quick enough in my opinion for output here. You've got your 12 volt port here, which now another thing that I really like is that it has a rubber cover. I can't tell you how many of these things, you know, they don't have a cover. And if you're going to be taking this thing outside, using this when you go camping, when you go to the beach or something like that, do you really want your 12 volt port filling up with sand? Now I get it, all right, the USB ports, they're still open, but man, that is a huge hole. The cigarette lighter port is just it's a big hole, and so to not have that covered seems kind of crazy. So that's nice. So let me go ahead and show you the interface here. We'll turn this on, and that's the standard Maxoak Bluetti setup. As you can see, you've got your 5 icon battery indicator. Again, come on guys, you can keep the battery indicator and then just put a tiny little percentage next to it. Is it that hard to do, guys? I get it, these displays are probably super cheap and you could probably buy them in bulk for cents on the dollar, but come on guys, you know, if we're paying this much for a power station, I would like a little bit more comprehensive knowledge to the charge level of my battery. But one of the things I do love about all these Maxoak Bluetti products is the very comprehensive input and output displays for power. So you've got a clear indicator here for input. You've got a clear indicator separation, by the way, for DC output and AC output, something that the Jackeries don't do. And so I really do like that a lot. The fact that there is, in fact, the ability to discern where am I pulling the power from? Is it from my DC ports or is it from the AC inverter? Let's flip this over and I will show you what's on the back. So we got on the back here, it's got our input. You can see here, 16 to 40 volts, 10 amp max. So, you know, again, if we do the math, right, 10 amps times 40 volts, you'd think the max would be 400 watts. But, you know, that wouldn't be the first time that they, you know, that somebody labeled something with that. But basically, it's mutually exclusive, right? So it's either 10 amps or somewhere in the range of 16 to 40 volts. It's not max out both of them. So we'll see. Here you have your inverter, 600 watt pure sine wave. One of the things that I found in the manual, because again I was unclear about this, is the surge potential is pretty low on this thing. They didn't give you a clear specified surge. So you right here, you see in the manual, it says if you put it over 720 watts, then you're going to be limited to 120 seconds of surge, and less than 100, greater than 606, but less than 720, you're going to be at 120. 720, you're going to be at 120 seconds, and over 720 watts, you're going to be at like half a second. So there's not a lot of surge potential, and so that could be a difficult thing for people with like air conditioners or anything that might have a surge. You know, your headroom is there's not a whole lot of headroom with regards to what you got on your inverter. Like a lot of times with these power stations, you know, they'll be rated for, let's say, 1,000 watts, but they can surge up to 1,200 or even 1,300 for a split second. But this unit really can't push it past even just like 120 over the max rating. So that's something to keep in mind. So another thing that I like about this thing is it has a light on the back. One click for high, one click for low, and the last is your SOS mode. So pretty simple. And then of course you've got your ventilation fan back here, as well as an intake duct up in the front. Now, if you're wondering exactly what this is, which is labeled external interface, you know, I was wondering the same thing, but it doesn't really give you much more information in the manual. You'll see here, it says external expansion port. And yet, if you look in the manual, it doesn't mention what that does anywhere else. You know, I'm guessing maybe this has something to do with like an external monitoring station or something, but this isn't actually anything I've seen on any other Maxoak Bluetti product. And so it's pretty interesting. Maybe they'll release something that'll work with that in the future. I thought maybe this was like a parallel port, and maybe you could hook up 2 units to parallel them to, you know, double your power output capability. But if you look in the manual here, you'll clearly see that it says, can 2 power stations be used in parallel? No. So I'm not really sure, because I thought like, oh, if it's a parallel port, that'd be pretty cool. That would be a lot like the EcoFlow 600 unit that they recently came out with that has parallel capability. And I thought, well, maybe this is like that. But again, Maxoak, if you're watching this, I'd love to know what this actually does. And if any of you guys watching actually do know what this is for, please let me know. I'm probably just stupid. Maybe I'm just stupid. I don't know what this is. But to me, this kind of reminds me of like some sort of external, like you'd attach like an external controller. So like basically you could remotely control this unit with a wired controller of some kind from a different location. So let's say you mount this in an RV or something, or in a vehicle that you're living in. If you mount this towards the rear of your vehicle, or maybe closer to where your input lines come in from your roof solar or whatever, it would make a lot. It would be pretty cool to have a separate monitoring display and controller that you could mount somewhere else in the vehicle, or even in an off-grid cabin or something like that, so that you didn't have to go to the unit to touch these buttons, especially if you kept this thing, like let's say in a cabinet or something like that, and you didn't want to have to, constantly keep the unit out and cluttering up your space. So that's what I was thinking this might be for. But anyway, so let's go ahead and test a couple things. All right, the first thing, let's test the load capabilities of that AC inverter. Now I'm very curious to see exactly what it takes to kick it off. So let's go ahead and I'll grab a couple loads. I'll grab a heater. I'll grab a fan. In fact, I'll grab 2 heaters. So we can see, can it actually surge or will it immediately shut off? So I'll be right back. All right, guys. So I've got 2 loads here. I've got 2 heaters. These are the best loads that I got. That'll work around the range that this thing operates. So this heater right here, I'll flip it over, is rated for exactly 600 watts. And this heater is rated for 200 watts. So in theory, and from what I found, usually the heaters run, initially they'll surge over what they say, and then they'll dip down to about, like 80 watts less than they're rated for. So I'm curious to see, first of all, if it'll even run this 600 watt heater, because it will surge initially, and if once this is running, exactly how much it'll take before it kicks off. Probably, if I try to run both, it'll definitely kick off. So we'll see. You'll see that it keeps powering off. That's because I didn't turn on either output. So if I turn on the outputs, it'll obviously stay on. But because both outputs are off and there's no charge input coming in, it'll shut everything off to save power. So first of all, let's go ahead and turn on our AC output. So both of these are plugged in the back. All right. So we'll start with the small load, which it should definitely be able to handle. This is a 200 watt heater. So you'll see the display there. We've got a very quick response. You can hear the fans kick on. I believe, yes, there is one in the front and there's one in the rear. So that is great to see. There is pass-through cooling. So basically it's pulling air from the front and exhausting it out the back. All right, so we're pulling 200 watts right now, 203 watts. And like I said, once the heater's on, it tends to go down. Since these are ceramic element heaters, the resistance decreases as the temperature goes up. All right, so we know that it'll run the 200 watt heater, no problem, as it should. All right, now we got the 600 watt heater. And because it's got a safety switch on the bottom, I'm gonna have to try and do something weird with my hand here to get it to turn on. Hang on 1 second here. All right, it surged. You can see it's up to 7. Oh, all right, guys. I don't think it's gonna run this heater. You saw what happened. It's given us error 36, which if we reference the manual is inverter output overload. So guys, that's pretty disappointing. It can't even run the heater, and it only surged up to 700. It didn't even give us, 720, so I was expecting it would be able to run it, but probably, yeah, it's not gonna. We can try this again. Turn off the AC inverter, turn it back on. No, yep, gave us an error again. So guys, you're really gonna have to be very calculated in what you plug into this thing, because that 600 limit really is a limit. There isn't even that much room for a surge overhead. So like I said, if you've got any high surge startup devices, like an air conditioner or a high draw start refrigerator, probably not going to run on this thing very well. So keep that in mind if you're planning on buying one of these or trying one of these out for your setup. And for you, maybe you'd be better off with the EB150, which is the 1500 watt hour unit. So okay, so we've established that. So that is the AC output. Let's go ahead and try some of these DC outputs. Okay, I've got a USB-C cable, or USB-A to USB-C, and we'll go ahead and turn on our DC output here. All right, I got this phone right here, and indeed we are charging. There you go. Let's also try the USB-C to USB-C feature and try charging my iPad Pro. All right, guys, got the USB-C cable here. I got my iPad right here. Sorry it's so greasy, guys. I've been doing a lot of work on it, and well, that's what happens with a touchscreen. And there you go. We are charging, and it is pretty full right now. The iPad, the battery is at 94%, so that's why it's not drawing very much. But you can see with the screen on, it's still drawing about 18 watts, and that's also, I guess, including this phone charging. So it is good that it's showing that even low wattage shows up. Some of these power stations, when you have a super low draw on them, the screen doesn't show it very accurately. And like I know with Jackeries, under 10 watts, they don't even show anything. So this is pretty good. You've got a very good display that even shows low power draw, which I do like. But what about the 12 volt port? Is a 12 volt port a regulated output? Well, let's go ahead and test. Now currently the battery is indicating about 80% charge. So we're gonna see what kind of voltage we get, and then I'll go ahead and put a load on, I'll put a load on the AC inverter side, and we'll see if that voltage sag is reflected in the 12 volt port. If it is, chances are it's not regulated. If it isn't, then that's a good indication that we do have a regulated output. All right, I'm gonna try and get this in frame for you guys. So there we go. All right, guys, we're getting 13.42 volts. That is looking good, but let's put a load on the AC side of things. I'll turn on the 200 watt heater. Got that going, and now let's recheck the voltage. Yeah, look at that. We're still getting 13.42 volts. So this is indeed a regulated output, and it's at a very good voltage. So unlike the EB150, which is the big Bluetti, go ahead and turn on this heater. All right. Unlike the big Bluetti, which is regulated at like 12.4, I think, volts, 13.4 is a very healthy 12 volt port output, and that is going to let you run any of your 12 volt devices with no problems at all, with a significant improvement on the power output of those devices as well. And so that is great, because one of the reasons that I personally actually was looking for this unit is that it was the smallest battery capacity that could comfortably run my CPAP with the humidifier on for at least 8 hours. Now, I get it. I could turn the humidifier off and, I could still use it. All right, guys, so we've tried out AC and DC, but now I think we need to see just how much power this thing can take charging. So how much input power can it take? So to run this test, I'm going to be using my external power supply, capable of a maximum of 300 watts, 30 volts at 10 amps, roughly. Although technically it can shoot over into 32 volts, but what we're going to, just for the sake of this argument, we'll say 300. Now, all the literature I could see on this thing says it's only capable of 170 watts maximum input. So now if that's true, it is pretty disappointing. I wouldn't say it's necessarily a deal breaker because it's not glacial, but it is pretty slow considering the capacity. Again, remember, you've got 900 watt hours of usable power in this thing, even if we take into account a 90% depth of discharge instead of, obviously 100%. All right, so let's see here. Let's hook up our cable. All right, guys, so I've got this thing hooked up. Now what we're gonna do is I'm gonna turn up the amperage, and then we're gonna see what we get. So I'll turn the amperage all the way up, and we're at 14.7 volts, and it's actually charging, believe it or not. Even though it said 16 volts, it is charging at 14.7. Let's see how low we can go before it stops charging. Okay, so it seems like around 13.7, 13.8 seems to be the cutoff. So now let's put it up to a nominal panel voltage of 20 some volts. All right, let's get this up to 20. Okay, it seems to not want to accept any more than that. So we're at 18. All right, well, wait, hold on a second, guys. All right, guys, so we got an error. E20 is solar panel over current. So unfortunately, guys, I don't think that is going to be a possibility. All right, guys, so let's try this again. This time, what I'm going to do is I'm going to keep the amperage low, but I'm going to crank the voltage because this thing can take up to 30 volts, right? All right. It's not accepting a higher voltage, as you can see. So we're at 142 watts. All right. Yeah, it won't take a higher voltage because you can see I've got the knob all the way to the right, but it's only accepting about 18 volts. And as soon as we're at 9.94 amps. If I cross over that even a little bit, I'm guessing it's probably going to kick off. Yep. All right. As soon as I crossed over 10, not even a little bit more, it gave us an error here. So it's looking like that is a hard limit of 10 amps. So 170 watts is going to be your limit, unfortunately. Here, let me see here. I'm going to turn off. So it does seem like 170 watts is going to be your limit, unfortunately, for power, which is disappointing, but not the end of the world. Just a little disappointing. So we'll see what we get here. So again, it seems to like pulling, right around 18 volts. And you can see that. If I increase the current output, we'll get it real close. I don't want to keep kicking it off, so I'll get, oops. All right, that's exactly 10 amps. So it's pulling in 169 watts at 10 amps. Wow, it still gave us an error. Wow, I guess that was too close to the limit. All right, let's try this again one more time, guys. All right, I'm gonna turn the amps to the safe zone. We're at 9.5. There's no way this thing is gonna kick off for an overload at 9.5. All right, guys, we'll turn this up just a little bit more. All right, we'll leave it there. I don't want this thing kicking off over and over again. But yeah, guys, so it would appear that the limit for input power is in fact 170 watts, which is disappointing because again, this thing is 1,000 watt hours. So that is going to be kind of a slow charge. So even if we don't account for the fact that when a lithium battery gets towards the top 20%, it slows down charging significantly for protection. Even if we discount that, at 170 watts to recharge 900 watt hours, which is what would be the usable capacity of a 1,000 watt hour battery, which has a 90% depth of discharge, you're looking at a recharge time of about a little under 5.5 hours. And of course, if we factor in the fact that charging rate significantly drops after the battery reaches 80%, that's not boding well for 0 to 100%. Now 0 to 80%, you might be able to do that in about 4 hours. But 0 to 100, I'm going to say you're probably going to get 7 hours. You're going to need 7 hours of 170 watts input. So this is probably not something that you're going to want to drain on a daily basis, because even if you've got a massive solar array, you're not going to be able to shove more than 170 watts into this thing at any one time. So that is your limiting factor. But since it's actually nice outside, why don't we go ahead and see how this thing plays with a little bit of real solar. Now, I do want to stress, all I've got for the test is this 80 watt Dokyo folding panel. It's one of these guys. And of course, that isn't even close to the input that this thing can take. However, that's all I've got, but given that you can get up to 40 volts in this thing, you could put 2 in series and probably get significantly faster charging just from the ability of the MPPT charge controller to better utilize the higher voltage. But that being said, why don't we go run that test now. Alright guys, so thanks a lot for watching. If you liked the video, definitely hit that like button. If you have any questions, comments, or your own experiences, if you actually have this unit, I'd love to hear about it. As always, links are in the description, but if you want to wait for my full review, you can always do that as well, but you can check it out for sure. Links will always be below. And if you want to see more, as well as my full review of this thing, don't forget to get subscribed.